This question is about organic molecules that have a strong smell. Part A. Thiols are foul-smelling organic sulfur compounds with the functional group SH. Butane 1-thiol, shown below, contributes to the strong smell of skunks. Part 1. Thiols are weak acids. Write the expression for the acid dissociation constant Ka for butane 1-thiol. The general expression for Ka is H plus A minus over HA. So that means that it's H plus and then a salt, which is A minus, over the compound. So if we were to apply this to butane 1-thiol, we would get Ka equals H plus and then C4H9S minus over C4H9SH. We can see that another way of looking at this equation is that the denominator is equal to both parts of the numerator. To get the mark for this question, you have to have the whole Ka expression correct. Part 2. Thiols react with carboxylic acids to form thioesters. Write an expression for the reaction of butane 1-thiol with ethanoic acid. Use structures of all organic compounds with the functional groups clearly displayed. If we start by writing out our reactants, butane 1-thiol would be CH3, CH2, 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 SH, plus ethanoic acid, which we would write slightly differently to represent the carboxylic acid functional group. If I highlight this, here is the carboxylic acid functional group, and the question is asking for all organic compounds with the functional groups clearly displayed. If we then write our products, well, we're forming a thioester. So a thioester, that means it's a similar ester group, and the general ester group would be as follows, with an R attached to either side. But it's a thioester, so it's going to have sulfur featured, and it would appear as follows, with the CH3 coming from the ethanoic acid, C double bond O S for the thioester, and then CH2, 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 CH3 from the butane, plus water. Because it's esterification, you always form water, it's a condensation reaction. For this question, you get a mark for the general equation being correct, and then you get a mark for your functional groups being clearly displayed. So in the ethanoic acid and your thioester link being correct. Part 3. When beer is exposed to light, 3-methyl-but-2-ene 1-thiol is formed, which gives an unpleasant smell and flavour to the beer. Draw the skeletal formula of 3-methyl-but-2-ene 1-thiol. If we break down the question and we look at the key pieces of information, we need to draw the skeletal formula. Then we can look at the individual parts that make up 3-methyl-but-2-ene 1-thiol. So looking at 3-methyl, well, that means it's going to have a methyl group on the third carbon. If we draw out but-2-ene, that would look like this, skeletally, with 4 carbons, 1, 2, 3, 4. Then we can draw the 3-methyl group on maybe carbon number 3. That could be our carbon number 3. Then our thiol group, well, a thiol group, that is an SH group, and it would be on the first carbon. So if here is number 3, then here would be number 1. So if we draw that in black to answer the question, our 3-methyl-butene 1-thiol, drawn skeletally, looks like this. To get your mark for this question, the whole structure needs to be correct and in skeletal form. Part 4. Propane 1,3-dithiol reacts with carbonyl compounds in a condensation reaction to form a cyclic organic sulfur product. Write an equation for the reaction of propane 1,3-dithiol with propanone. Use structures for organic compounds. So if we begin by writing or drawing out our reactants, we firstly have propanone, which would look like this, drawn skeletally, with 3 carbons and a ketone group. Next, we would draw propane 1,3-dithiol, which would look like this, with our propane and 2 thiol groups attached to the ends. This would produce what we're told in the question, a cyclic organic sulfur product. So, a cyclic product, that is going to have to show this in our product. And it would look like this if we were to combine the propanone and the propane 1,3-dithiol. We're also told that it's a condensation reaction, therefore our second product would be water. To get the 2 marks for this question, you get 1 mark for your reactants being correct and 1 mark for your products being correct. B. The structures for 6 naturally occurring organic compounds with pleasant smells, B to G, are shown below. The common names in brackets relate to their source and smell. Explain how chemical tests would allow each compound to be distinguished from the other compounds. In your answer, include essential details for all test procedures and observations. Details of apparatus and quantities are not required. So a question like this is quite a common one, and it's asking about tests for functional groups. So whenever you're asked this type of question, look at the compounds and label the functional groups, because you get marks for this, and that means you don't need to write a lengthy explanation. You can just simply label them. So if we start with B, we've got 2 alkene groups. We can just write that here. Then we've got an alcohol group, but you need to be more specific when talking about alcohols because there are 3 different types. This is a tertiary alcohol because there are 3 R groups attached. 1, 2, 3. Moving on to C, we've got 1, 2 alkene groups like B. And we have an aldehyde group. It's an aldehyde because the carbonyl group is on the end of the molecule and there's no OH attached, so it's not carboxylic acid. In D, we've got 2 alkene groups like before, and then we've got an alcohol group, but this time our alcohol is a primary alcohol because there is 1 R group attached. Moving on to E, we've got a ketone, and we've only got a ketone in compound E as our functional group. In F, we've only got an alcohol. Again, making it more specific, we've got a secondary alcohol because we have 2 R groups attached to our alcohol group. In G, we've got 1, 2 alkene groups, and we have a ketone. Next, we need to lay out our testing in an effective way. An effective way would be as a flowchart or a table. I'm going to draw a table. Our first test, because we've got a lot of alkene groups, is bromine water. And if there's an alkene group, it will decolorize bromine water. So you could also write that this is a test for alkenes, just to show to the examiner you really know what you're talking about. And then if we write our compounds, and we can make this into a table. It doesn't need to be really smart or neat. Obviously a ruler would be helpful, but it's okay. So B is a positive result because there is alkene group like C and D. There is no alkene group in E or F, but there is in G. So you can see how labelling the functional groups makes this a lot easier to do. Then our next test would be 2,4-DNP, and it's an orange precipitate we're looking for, and that would be a test for a carbonyl group. So if we write that on the side. So the carbonyl groups we have are in C, the aldehyde. We also have one in E, the ketone, and one in G, another ketone. Our next test could be Tollens reagent, and that would be a silver mirror produced, and that's a test for an aldehyde. There is only one aldehyde out of our compounds, and that is C. So we would put a tick next to C. Finally, we would test with acidified dichromate ions, and we would hope for a colour change from orange to green, and that is a test for primary, secondary alcohols and aldehydes. So if we tick, we've got tertiary alcohol on B, so there's no oxidation that occurs, so we won't have a result. In C, we've got an aldehyde, so we would have a result. In D, we've got a primary alcohol, so that would be a positive result. F, secondary alcohol, that would also produce a result. And there we have it. This is a level response question, so there aren't exact marks. You get marks for detail and how you've answered the question. So labelling your functional groups, that gets you your first 2 marks. If you've missed one out or you've only labelled alkenes once, it depends on the examiner whether you'd get that mark. Your next marks are for the tests that you do and the positive results that you're saying. They're the next 4 marks, and then if you've correctly put ticks and crosses or left them blank, we could write crosses just to confirm that we know they would have no reaction. But it's not essential. Okay, and this is how you answer part B.